So we're going to do an impromptu plotting. Plotting was supposed to show up mid this class, but we're just going to do a very small plotting exercise right now. Okay? So the basic way MATLAB plots. My MATLAB open. Console. Yes. I need to open correct MATLAB application. Just give me a second. So a very basic MATLAB plot, and then we're going to get to reading and plotting data in a second after this, is as follows. Plot x, y. And your x and y's are basically x and y coordinates of the points you want to plot. So let's do a very simple one. Let's x be 0 and 0. Okay? And y is 0, 1. So these are two vectors. Okay. The first point is 0, 0 in my Cartesian coordinate system, so x and y coordinate. And the second point is 0, 1. Okay. So I have 2 points. Okay. If I just say plot x, y, I'm literally going to get that line. By default, MATLAB is going to connect the points that you're plotting with a line. Okay. If I added a third one, let's say that my x is 0, 0, 1, and my y is, what was my y? 0, 1, 1. Okay. Okay, so actually you don't see the line here. I have to, and you can drag the plot. Take that little hand and you can drag it so you can see the line. Okay. So it goes in order and connects my first point to the second point to the third point, and so forth. I can modify whatever you see on the screen, you can modify. So I can just say, well, I don't want lines because lines possibly don't make, if I'm plotting a triangle, great, that makes sense. So the way I would make a triangle out of it, I would just add the same starting point and x. So just added the starting point at the very end. And then it's going to plot the entire triangle, right? To see the blue line. Type it in with me. Again, this is my x, and this is my y. Now this is with plotting lines. Say you don't want lines. Okay. You can just do something like this. Let's say I want stars where those points are. It replotted and you can see a star. It's kind of hard to see on the screen, but you can see a star here. You can see a star here, and you can see a star here. What seems to happen every time I plot? What happens to the old plot? Gone. If I don't want it gone, if I want things on top of each other, I can just say, hold on. Okay? And plot again with lines. You can see that it also automatically changes colors a little. And if I'm happy with the automatic choices, I just don't do anything. But there is a way, of course, to change those colors. You can click on things and try to change parameters. We will learn how to change all of those. Yes?
What's the fourth number do?
So these are my x's, and these are my y's. So it connects the last two. So when I plot from this point to this point, that's my first line. Then this point to this point, that's my second line. This point to this point, that's my third. I needed a third line to close the triangle. Because that's what I want. That's what he wants. I came in wanting something else. Okay. So this is now, everything else is now knowing which x and y's to give MATLAB to plot. So key in every plot is that you have to know precisely what to give to MATLAB to plot. Precise coordinates. And then it's going to plot it. 2D, 3D, doesn't matter. Okay, there's plot 3 as well. I could do helix if I wanted to. Okay? I just need to know the points of that helix to do that. And things will lose, like basically here we have a very simple case of 3 points. Okay? But you can do a very wavy line. Okay? And it's going to look really smooth, but all that line is a number of consecutive points. They're just so close together that you can't tell the difference. Okay? Yes?
So, I think you just explained this, but I don't think the hold on worked for me. Once you plot the triangle and then you want to put points inside it, you just type in hold on.
Yeah, and it's just going to add it on top of that plot. So let's add any point. Hold on, plot. Give me a point inside. 0.5, 0.5. I think this should work. Oh, it's going to do a line, sorry. Let's do something else. Diamond. Diamond is a D. I'll give you the list of things. So here's the diamond. Okay. I can do 0.7 as well. So I added another diamond. You just have to point based on your component analysis. You have to figure out where that point needs to be in the middle of the triangle. And that's a geometry problem on a piece of paper. Okay? So this is for all of you who are in thermodynamics, how to plot a ternary diagram. If not, hold on to it. You will need it next semester in your thermodynamics class. Yes?
Is it possible to have 2 figures open?
Yes. Okay, great question. So say, of course, this is one plot, but I want multiple plots because I want to compare things. I'm going to say figure. That opens a new figure window. And whatever I type in afterwards goes to that plot. And I can keep going. And we're going to add details to this. This is just an impromptu question. And it's actually really related to the class later today. So, okay. Now I'm going to, where did I start with quizzing? Who was the last person I quizzed last time? My memory is bad. It was somewhere here in between, right? Were you the last one? No? Were you the last one? I think so. So you're next. All right. So basically now let's say I want to plot a sine curve between 0 and t. For my x's between 0 and p, I want to find y's that are sine of x, and I want to plot that curve. What do I do? How do I get those x's first? I'm giving you a hint here. To pi, and give me some spacing in between. Pi over 4. Cool. Okay. And then how I'm going to compute sine of all of those x's. Simple, yeah. This is what we love about MATLAB. Okay. So it's going to do actually sine of all of these values that I gave it to. And now I want to plot this curve. What do you think I type in? It's as simple as it sounds. Now this sine is not very smooth, is it? So I have choppy line because my resolution is kind of very choppy. because all MATLAB does, it connects a straight line in between every 2 points I get. So the person next to you, how do I fix this? How do I get a smoother line? What do you think?
If you lower the pi over 4.
How about 40?
Yeah.
Okay, so now I have 40 points and I reevaluate my y and then I plot. Now that's way better. Okay. I could have, of course, done the full. So I'm going to do 2 pi and reevaluate and then plot. And then I actually have something that I recognize as a sine curve, right? Because I'm on a full period of sine. Okay? So plotting is simple. You just need precise coordinates of the data you're plotting. Okay? Yes?
In the x function that you declared before, so pi divided by 40, what if you replace 40 with
Infinity. Then you're going to have
smoother?
an error.
Yeah.
You cannot get infinitely smooth. It can appear to a naked eye, this looks as smooth as it's going to get.
It's like there's no direct way to like make a smooth sine curve.
Okay, this is a great point. Every time you're doing something numerically, there's no such thing as infinitely smooth. You're always evaluating at a bunch of points, and they might be, as even this screen, okay, the screen is pixelated. And the reason why it appears smooth to you is because it's 1,000 by 2,000 or whatever the screen resolution is. And that's so good that your eyes don't see the difference. But if you zoom in enough, you will actually see pixelation and differences between it. So if I zoom into this, you can actually play with zoom in, by the way. So I'm actually going to plot these with stars just to see how close they get. Here they are. Okay. This is the actual points I'm plotting. All of the lines in between are straight. Okay. But my eyes are not good enough to actually see when there's not many points. Okay. And for most engineering applications or any other, it's actually good enough. Okay. No need to go into infinity. And again, you can play with this. So there's this little plus and little minus, so you can zoom in like that. This is zooming in. And if you play with a minus, you zoom out. Questions? Okay. So let's now backtrack to where I wanted to start the class. This is actually a good introduction. So last time we did saving and loading data into matrices, and now I would actually like to plot that data. So if I can create myself this x and y's, I can plot them any way I want. But we know in petroleum engineering, often we will have measurements. And without measurements, we don't even start doing anything. Okay? And in your homework that was just assigned, you will have a bell log that you will work with. Okay? And that data comes into you. It's not a sine function. It's not as pretty. Okay? It's actually pretty ugly. Okay? But you have to plot the data that you work with, the measurements that you work with. Okay? And for that reason, we need to know how to read in the data from a file and then plot it. So for that exercise, okay, I will basically, I posted a file called pdx head, T is in temperature, dot, and it's in Canvas. So if you go to Canvas, you can download it from MATLAB subfolder. So in files, there's MATLAB, and here it is. Okay. So now it's also a great time to mention, so when you download, your computer typically chooses where to download, but that's a location. Okay? It's a folder somewhere in your computer. And you possibly either need to change your directory, your working directory, so here you're working in a directory, and I can't see that file here, so it's not in my current folder. Right? So you need to figure out a way to move that file from wherever it was downloaded to the folder you're working with right now. So basically I'm going to try to drag and drop. Let's see, my downloads are here. Here's the file. Try to drag and drop. And yes, MATLAB is that good. So I dragged it from my downloads in my current folder. If I open the file, I can actually see some data in there. Apparently it has some issues reading things. You can also type from command line. And you will see something like this. So if you just literally put type and name of the file. So did everybody download and move to the folder? Can you move to the folder, this one, drag it into this current folder that you have open. So drag it from whatever downloads. There's a download directory on your computer somewhere. Okay. So please do this type. So with type, you literally see contents of a text file. So what we have in here, it's text file, it's human readable. I have a line that says me, okay, this is month, this is high, low temperature, and average temperature. Is this in Celsius or Fahrenheit? What does it look like?
Celsius.
Celsius. You have 63 Celsius somewhere on Earth? Do? I don't want to live there. Wherever it is. I think this is Fahrenheit, but it's not in Austin, is it? Average temperature of 68 in the month of August does not sound like Austin. Canada somewhere, wherever it is. That's actually too cold for my personal top temperature of 80 Fahrenheit in August. That's cold. I don't go swimming at that temperature. All right, so what did I actually point out right now? You got the file from somewhere. I'm telling you it's temperatures. Look at it. See whether it makes sense. What can you make out of it? What is the missing information? I don't know whether my file doesn't say whether it's Fahrenheit or Celsius, but I have enough reason to actually gauge that myself. Okay? So always do that with data. Don't just expect to go on auto and work with it or plot some. This is temperature, so it's something that we can definitely talk about, right? So now that we figured out that this is somewhere from north of here, I would like to read that data and actually plot the temperatures, like I have a temperature report either online or Weather Channel or whatever it is. Okay, these are measurements from somewhere. But the problem is, like, so what did I say? What can I, when I'm loading text file, what is one of the functions that you mentioned last time that you've used? What's my next one? There's a function that can load the data. And the name of the function is load. So let's try if it works. Hint is it's not going to work. So we'll have to do something else. But let's do. Let's say load. So it has errors, unknown text, something, something. Essentially, the problem is that there's text in it. If it was just numbers, I wouldn't have issues.
So just text meaning the word like
Actual letters, and it's expecting a numeric value. That's what a load is designed to work with. Okay? So we can't do that. So we need to actually learn how to read this file directly, and that is essentially the what we are going to do today. And I'm just going to briefly go to the lecture, okay, that first outlines what we're going to do, and then we're going to do it. Okay? So when I have a case like this, my first directive has to be open the file. Okay? And that directive is fopen. Okay? It comes from file open, fopen. So fopen, name of the file, okay? And you have to tell it to open the file for reading. You could open the file for writing as well. Okay? Or appending, which means adding to it. So that's the first thing we are going to do. Once we open the file, all you did is you went to the location of the file wherever it is stored. It's stored in that folder. And you're just sitting there at the beginning. You open the file and you're waiting for further direction. After that, I have two different types of data. One is text, and I need to treat it as text. And some of it is numerical. And you will see the well log that I sent is actually going to have some text, certain number of lines of text at the beginning. You kind of have to read in and then ignore, and just get to the numbers afterwards. You don't ignore it, you read it so you know what's in the file afterwards. So we read it, we know that the first column is month, second column is high temperature, third column is low temperature, and the fourth column is average temperature. That's what this first line is telling me. So I'm going to read those headings. It's file, get, line, F, get, L. And FID is my current address, or how I refer to it in MATLAB. Yeah, that's the address that is going down my file. So I'm just going to get that line out of the way, and then I will scan the file for floating point data. Floating point is the real numbers. Okay? And this is just telling it that the format of the numbers to expect a real number format, which is called floating point in computer science. And MATLAB is smart enough that it's just going to read as many numbers as it can find and close. Not every programming language is as smart. Okay? So this is very convenient. I don't need to know how many. I just go and read. But there's 48. There's 4 times 12, right? And then I'm just going to close the file, and I have my data. I'm going to manipulate it. So let's do that step by step. Okay, so first thing that I'll do, I'm going to say FID, which is short for file ID, fopen, pdx, thead.dat, and I'm going to say for reading. When my FID is a number that is larger than 0, I know that everything went well. Yes?
Why did I get -1?
Because it didn't find your file. So if, let's say that I put just X at the end, obviously this file doesn't exist, I'm going to get -1. So you did not move it to the current folder, whatever your current folder is. Okay. So if you get a -1, it means it doesn't know where the file is. Whatever, you have to either move, so it has to exist in this current folder, the file that you downloaded. All right. So next thing that I'm going to do, I'm going to do headings, is fget line of FID. Oops. Don't put this in, sorry. So this is just a line of text. Yes.
When you were doing the file open and like other than it being negative, does the number that it burps out matter?
It doesn't. It's
Okay.
whatever comes in your error. So if I do it 10 times, the numbers will get larger and larger because for every next one, it's going to give me a larger ID. But the positive means I found the file. Yes.
Is that an L? F get L?
Yes. As in file get line. Okay, so it gets the entire line. If you forget what F get L means, what are you going to do? Help F get L, and then you will get how to use it. Okay, so now headings are out of the way. So now if you think about this FID as a little address that is moving along, okay, now I'm at the beginning of the numbers. Okay, so now I'm going to read those numbers. D is F scanf FID, and I have to tell it what to look for. Look for floating point or real numbers. It could be integers, it could be other things.
What does that percentage do?
Percentage just tells it this is a format. So it's a sign for MATLAB to, okay, this is going to be my format. Read it as a format instruction. Otherwise, it could be a different other instruction. Okay. And all of those numbers are read in. What is my size of this D? There's 48 numbers. So to actually put all of them into one long array. That's not necessarily what I want, so I'm going to use Reshape that we introduced last time to get there. So how did it read the numbers? Let's look at the first 4. This is the first 4 of the numbers in D, right? 1 through 4. So this is that month of January. High temperature of 45, low of 33, average of 39. Obviously not Austin. Okay. And then if I look at the next 4, 5, 6, 7, 8. Okay. Then I have month of February, high, low, average, and so forth. So just length down each line, and those 4 numbers are now in the column, and the next 4, and the next 4, and so forth. You have an error. You did not. Oh, your D is actually already reshaped. You went ahead and typed in everything in the slide. Hold on. So now I want to reshape this just simply to see the table that I actually see in the file. This is my table from the file. I would like that first 4 numbers to be in my first row of a matrix. Okay. How does my reshape work? Do we remember? We do? How does reshape work? So if I have this D, what is the reshape going to do?
You choose either variable and then equal to reshape, times is a different variable.
And then number of rows times number of columns.
Yes, product, yes.
Okay. So what would be a smart choice of rows and columns? So reshape is going to go down that line and take my first row numbers and put them in the first column, and then the second and third and fourth. So maybe I should go every 4, right? And then the rest of it is I have 48 total, so 4 by 12, right? So you have to choose that. You have to look at the data and choose. What I have here in file is one case. You will have something else next time you open a different file. So you have to look at the data and understand that reshape will go down the column. And even if I have a matrix, it's going to go down the first column, the second column, third column, in grabbing the data to fill the new matrix. Okay? So basically, I'm going to say I'm going to call it D1, is reshape, okay, my original D into 4 by 12. So if I want to see my first row of D1 that I just reshaped, my next in here, how am I going to look at the first row of D1? I need to look at this a little better. There's this column here printed. I don't know what's going on. I want to look at my first column. So my D1 is a matrix. If I check size of D1, it's 4 by 12 as requested. So how can I look at the first row of D1? 1, yes. And then everything in the second row. So colon is everything. There we go. So that's obviously all of my months, right? Then the second column is my high temperatures. The third column is my low temperatures and my averages. Yes? If I wanted to plot this, I could simply go plot. So my month is my D1. So those are my months. Sorry, this first row. And T high is D1 of 2. So this is my high temperature.
Can you explain how very top thing again with the D1 for
This, all right. So what I'm doing here, I'm investigating my matrix. Okay? 4 means fourth row. Column means everybody in that fourth row. Okay? So if I wanted to isolate just one element,
what is D1?
D1 is D1 was what I reshaped this business. This is what I typed in. So this is a matrix that is output of this command that we introduced last time. And reshape takes my D and reshapes it into a 4 by 12 matrix. Okay. Quick recap on the reshape. This is what we said about reshape last time. So if I had some matrix to begin with, my reshape grabs data column by column and fills in this new matrix according to how many rows and columns I told it to. Now my D to begin with was this very simple matrix. It was a 1 column. So when I reshaped it to 412, it took first 4 numbers and put it in the first column. Right? Second 4 numbers in the second, and so forth. So that is this. Okay? So that is my D1. And to just isolate, I can now see the way it's printed that the months are in the first row. And if I just want to grab those months, I say D1 of 1. So that's my first row and everybody in the first row.
So colon means row.
Everybody. The colon really stands for everything. Okay? So everybody that has 1 is a row. Okay? Now I could be more specific, so I could just say 1. So that's my 1, 1 location or 1, 2 location. I could also use colon as 1 through 4. So that's first 4 numbers in row 1. It's really convenient. You can combine it in any way that makes sense for you. And by investigation like that, I figured out, okay, my first row is my months. My second row in this D1 is my high temperature. D1. Okay. Has everybody caught up to? How am I going to plot it? I want to plot my high temperatures versus month. Plot. First row, second row. Plot. And I already isolated this first. What I already did before is I said month is my D1. My first row is now month. My T high is my second row. And then I plot month T high. And that went to figure, here we go. And if you want this font to be larger, there's a magic command saying set, I think, 8GCF font size. Now this will look cryptic, but font. Apparently I forgot how to use it. Oh, GCA, never mind. And that basically increases my font size here. Just take it on the face value for now to make numbers more visible. How am I going to add my low temperatures to this plot? Hold on. And then plot. It's not T high, it's T low, but T low is sitting where in that matrix? Which row? 3. I can actually just do that directly like this. It's not pretty, but it works. And now I have low temperatures. And I can, of course, go all the way and add the 4th row. Those are my average temperatures. Yes?
Even when I do hold on, it's not
Holding on?
Oh, okay. No,
You have to type it in.
no, I understand why.
Yeah, if you like close the graph and just say hold on.
Well, there's nothing to plot on.
Yeah. Okay.
If you want to stop it, hold off. That's called toggle. So a lot of these on-off commands, they go hold on, hold off as you go. So you just type in hold off and then it's going to stop and open your plot. So yeah, if you close the figure, there's nothing to hold on to. It's pretty simple. This machine can actually look logical sometimes, right? Questions? Now, if I wanted to, for some reason, or maybe because I asked you to, so this D1 gives me months in the first row, then high temperatures, low temperatures, so row by row. If I want to change that to look precisely like that file where I have month in the first column, high temperature in the second column, not second row, and so forth, what should I do? What should I do to D1? What's the name of that operation that switches rows to columns and columns to rows? Transpose. So D1 transpose gives me precisely the way file looked. Okay? Yes?
How do you undo a plot?
You close it.
And you have to put it on the plot.
Yeah.
That's the only way.
But, so what will help later on is you can collect all of the commands you did, okay, into a little script and then just execute that script again.
And you can keep changing the script.
Okay. Everybody wants to jump ahead and do that right now? That's down the line in our curriculum, but I can show you right now. Yes? So any kind of anything that you want to plot, Okay, you can say new script here. And I'm just going to make a very simple script. I could collect these commands here. Or I can just say, what was it? That x was 0 to pi over 40 to pi, 2 times pi. Right? I'm going to replot what I did at the beginning. My y is sine of x, and plot xy. Let's say that I don't want to retype that every time I want to plot it again. I'm going to save this as, and I'm going to call it plot sine .m. .m means a MATLAB file. So now I have saved my commands as sequence. I can just say plot sine, whoops, not here, in command line. I can just say plot sine, and it's going to plot things. And it added it to my temperature plot, which is not what I want. So I'm going to close it, and I'm going to execute it again, and then I'm going to have a new figure somewhere. I'm going to say close all figures and redo it. All right. And then I just have plot sine. So this saves just the commands, and you can re-execute them anytime by typing the name. And that's essentially what you're doing when you're saying load or fget line. There's .m file somewhere that gets executed with the input you gave it. Okay?
How do you plot it again? You just type plot.
Plot sine. The name of your file, and my file is sitting here, right here. You can also open it here in the editor. So let's say that I close it in the editor, and I double click on it, it's going to open. And you can do a run. Boom. Okay. And if you want to close all figures, you say close all. Okay, so now that my figure is closed again. And why it's useful is that, okay, you want to change something. You change it. I changed here to that rough resolution. Save. Execute again. And you don't like it, you change something else. I want to super smooth. I want red color, not blue. Save. Exit. Whoops. Oh, not that in the plot. Dr. Pradanovic, you get an F here. So I want to change the color to red. I change that. And now it's red. Okay. We can always dress things up. Okay, that's going to be the topic. But one thing that I'm super always annoyed is the font size, because I have thick glasses here and my fonts need to be big. Professionally speaking, if you're making PowerPoint presentations or giving something to your manager, the font better be readable. If half of your audience is doing this, not good. You're not going to sell anybody anything. Okay? So I could actually, that magic command that I actually forgot at the beginning, I can do that, and I can make it part of my plot sine routine up there. So every time I do it, it executes again and makes my fonts nice. Okay? I can also tell you that if you give plots to Dr. Balhoff or Dr. DiCarlo up there that don't have fonts that are large enough, good luck. So let's learn this command right now. Yes?
What's GCA?
GCA actually takes current axis. So it's the currently active, it's sort of a code for currently active, these are axes. And they have an address, so to speak, so that's their address. So you're going to grab that plot that it just plot, okay, is the currently active one, and set the font size to 16. All right? All right. See you on Monday, and a fair warning, you're overdue for a quiz on lecture 1.